Hi, welcome back to Algebra 2. Today we're going to be doing lesson 7.2, which is even and odd functions. So recall that functions are simply rules that convert inputs into outputs. These rules can get placed into various categories such as linear, exponential, quadratic functions, and so on based on their shared characteristics. In this lesson, we'll learn about another way to classify some of these functions that have useful symmetries. So the even function, I already have that circled, basically has f of x equal to f of negative x for every value of x in the domain. So what that means is if the point x comma y exists on a graph, the point negative x comma y also exists. So this is going to be a little confusing for the time being. I'll show you some examples. I promise you it will be easier to understand. And an odd function basically says the same thing, but it says if the point x comma y sits on the graph, then the point negative x negative y also sits on the graph. All right, so like I said, I'm going to show you a couple of examples of these two types of functions, but also recognize that not every function classifies as one of these. So the answer could be neither, and I'll close that out without lesson, okay? So I'll show you an example of that too. So let's take a look at exercise 1 from a graphical standpoint. So consider the partial graphs of the functions f of x shown twice below. So sketch the other half of the function if a is an even and b is an odd. So let's pick 3 points. So the 3 points are kind of given to us, 1, 2, and 3. So for this function, we have 0, 0. We have 1, 2, 3, 1, 2, 3, 4, 5, 3, 5. And we have the point 1, 2, 3, 4, 5, 6, 7, 1, 2. 7, negative 2. So these are the 3 points they give us. Now, in order to be an even function, basically it means that if the point 0, 0 is there, then the point, remember, I'm just going to remind you what it is. An even function is x comma y exists, so does the point negative xy. So if we have 0, 0, 0, 0 remains on the graph. So that's the same point. 3, 5, if 3, 5 is on the graph, then negative 3, 5 should be on the graph. 1, 2, 3, 1, 2, 3, 4, 5. And if 7, negative 2 is on the graph, then negative 7, negative 2 has to be on the graph. So see what's happening here. All right? The y's are staying the same, and the x's are changing signs. So 1, 2, 3, 4, 5, 6, 7, 1, 2. So this is the other half of our graph. So this is called an even function. Oh, duh, look, points are right here. Okay, so now we have the same points over here on this side, the same 3 points that we have. So we have this one, and this one, and again, I give them to you here. So our original points, I'm going to put them back up here again, 0, 0, 3, 5, and 7, negative 2. And now let's see what happens when we use our odd function. Xy means that negative x, negative y is also on the graph. So 0, 0 remains. Negative 3, negative 5 has to be on the graph. 2, 3, 1, 2, 3, 4, 5. And negative 7, positive 2, 1, 2, 3, 4, 5, 6, 7. Positive 2 is up. Oh, negative 7, positive 2. That's right. So this is the other half of an odd function. If you need to pause and finish writing things down, feel free to do that. Once again, I remind you, watching me first and then writing it down is most of the time a little bit more helpful. All right, C says, describe the symmetry of the even graph and the odd graph. Use as technically correct terminology as you can from your studies in geometry. So we're going to be talking a little bit about reflections here. So describe the symmetry. Even functions. So how can we say something about even functions? Take a look at this. Using our terminology and what we know about our transformations in geometry, what can we say about this? Well, even functions, and this is just not a coincidence, is going to reflect over the y-axis. All right, so let's rewrite that as even functions reflect over the y-axis. Did I say x? Silly me. Over the y-axis. All right, and odd functions, now, this one is not as easy to remember. Odd functions, this is called point symmetry, or you can say it reflects around the origin. All right, so odd functions have what's called point symmetry about the origin. So just to remember what point symmetry is if you have a point that's over here, so we went 1, 2, 1, 2, 3, 4, 5, 6, 7. To get the other point, we go in the opposite direction. 1, 2, 3, 4, 5, 6, 7. Instead of down 2, we go up 2 to get our other point. All right? But if you can remember the little laws that I just told you up at the top, then all is golden. And it's kind of easy to start seeing what they look like. Even functions are easier to pick out than odd functions, but I think you'll see the point symmetry just as easily. All right, so when you're done with writing all that down, meet me at exercise 2. All right, so some functions you've seen in your studies so far are odd, they're even, and some might be neither. That's what I was just talking about. So let's take a look at a variety of functions and consider whether they fall into one of these categories. So the first function is f of x equals absolute x minus 4. So now again, I'm not asking you to do anything crazy here. If you're home, this is a little bit harder to do unless you want to use Desmos and grab the graphing calculator off of that website. But basically what this looks like, and if you take a look at a table, let's create a table. This one has a vertex of 0, -4. So that's down here. And then it reflects around it -1. Oh, I used my word. -2, -3, and 1, 2, and 3. So this is -3, -2, -1. And this is -3, -2, -1. So 1 is -3, as is -1. Here, 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 here. And you can start seeing your pattern coming out, your nice V pattern. So absolute x minus 4. So that's what this looks like. So evaluate this function for a variety of opposite input pairs. What type, even, odd, or neither can this be? Well, if you take a look, we have -3, -1. Also included in here is +3, -1. And then we have -2, -2. But also we have +2, -2. So these are some examples of even functions, because we remember in an even function, if we have x comma y, we're also going to have -x comma y, which is basically what we have. All right, now this is using some points. All right, I think if you basically were to say this is an even function because it reflects about the y-axis, I think you'd be perfectly fine. All right, so either one of those examples would be acceptable in determining this is an even function. So let's take a look at the next one. Again, pause if you need to. So here we have g of x is equal to x cubed minus 4x. Now this is just a sketch. So let's see if we can come up with, let's put it in our calculator. I don't do anything crazy here. You can do it by hand, but so much easier to use our calculator. So when we put this in our calculator, these are the values that we get for the table that's given. Now, 5, 10, 15, negative 5, negative 10, negative, okay, so then we have 4. So 2, 1, 2, 2, 1, 2. So close enough. So what does this look like on our graph? So negative 3, negative 15. Negative 3, negative 15 is somewhere around here. Negative 2, 0 is up here. 1, positive 3 is not quite 5. Then we're at 0, 0. Then we're at 1, negative 3. And then we're at 2, 0. And then we're at 3, 15. So remember, this is a sketch. A sketch means obviously we're not doing this. We're not doing this with a 100% accuracy here. But dang, I think I did a good job. So take a minute and draw out that sketch. And like I said, when I did this, basically what I said is, well, here's 5 and here's 10 and there's 15. Here's negative 5, here's negative 10, there's negative 15. So here's 1, 2, 3, 4, negative 1, negative 2, negative 3. You don't necessarily have to put the numbers in, but you might not know what my tick marks mean. So what type of function is this, and explain? So I think that we can say this is most definitely, so this, I keep telling you, do not use pronouns. Let's say g of x, be more specific. G of x is an odd function, not an odd function. And you can probably say because it has point symmetry. If that is still unclear to you, basically what that means is that xy, if xy is on the graph, negative x, negative y is also on the graph. And that's the case here, because we have negative 3, negative 15, and we have positive 3, positive 15. We have negative 1, positive 3. We have positive 1, negative 3. Again, if they were to ask you, remember the almighty they, the powers that be, were to ask you, why does this have point symmetry? You can just use your regular words. You can say, well, if one point is on it, then the point with opposite signs is also on it. All right. You can also say it's got point symmetry. Technically, you should say about the origin, but point symmetry is probably all you need to put down. All right. So exercise 4 is the simple exponent y equals 2 to the x, odd, even, or neither. And it says support your argument with numerical evidence. So here it's not asking us to graph it or do anything else. It's just asking us to consider what it looks like. So y equals 2 to the x is a typical exponential function. So basically what this looks like, oops, I don't want this color black. It's an exponential function that looks like 2 to the x. Looks like this. Crosses at 1. All right, so this is an example. So now just looking at this, you might be able to look at this and say, well, it's definitely not even because it doesn't reflect over the y-axis. It doesn't have point symmetry because to have point symmetry, it has to kind of go through the origin. So if there's a point here, there should there would normally be then a point down here, which there's not. All right, and if there's a point here, there would be a point down here somewhere. All right, so this is not either one of those, but you need to make sure that you can support your argument. All right, so again, we know f of x is not even because anytime we have an xy, we do not have another point that is going to be x comma negative y. And now you might want to actually have a table going here. So table xy. So when x is, let's say, negative 1, we have 2 to the negative 1, which is 1/2. 0 is 1, and positive 1 is 2. So you only need to show one example. So in other words, if we have the point negative 1, 1/2, then the point, if this is even, should be the point negative 1 comma negative 1/2, and that is not true. All right, so because this is not the case. We can make the same argument now for f of x is not odd because x comma y should also be negative x, negative y. So we can use our same example. So we can use negative 1, 1/2 should be then positive 1, 1/2, which again, this is not the case. So it's important to make sure that when you are looking at odd and even functions, that you're not only considering the reflections, but you're also considering the rule, because sometimes you will be asked for numerical evidence versus graphical. So that's it for today. Until next time, make good choices.